Hello, how are you guys doing today? My name is Tito, and Raphael and I have created Hot and Cold. And if it sounds like I'm reading off a bit, it's because I am, so forgive me, please. But Hot and Cold is a cutting edge mixed reality game merging WebXR and zero knowledge proofs for an immersive, privacy enhanced gaming experience. And we'll break down that word salad a bit. So, again, the team, Rafael Campos, he was the Web3 and ZK developer based out of San Jose, and me, Tito Thompson, full stack of Web3 developer based out of Boston. And so here we're going to break down the milestones a little bit. So what we actually had to start is initializing the WebXR experience. And so we both got the MetaQuest 3. So we demoed this all with that. So no promises on how this works with any other XR device. And specifically to render it, we use Three.js, React 3 Fiber, and Coconut XR for everything regarding the WebXR experience. Then we had access to the user's environment. And so through the WebXR standard, and with MetaQuest emitting all the data, we get access to the spatial setup of the user. And this is very key. This is important because otherwise this wouldn't be possible. Right. And from there, once we know it's all set up and we have that information, we integrate the physics. And we use Rapier, specifically React 3 Rapier, to get this done. And for demos, we just created a ball, then mess with that ball by adding physics to all the walls and the furniture in the room and the global mesh itself, and just toss it around. See, and once that worked perfectly, we moved on to the next step, which was essentially just finalizing the single player aspect of the game. And that is laid out in the sandbox mode, which you could go test out. Anybody could go do. You could go do it right now. All it is just two balls, and you throw it around, and we were able to test in there, get a feel for how React 3 Rapier and WebXR integrated together. So, bam, from here. Next, we developed and deployed the ZK app to Berkeley testnet. So at first we were running it locally, and then ultimately, of course, we uploaded it to Berkeley. And there are two main methods inside of our smart contract. One, the commit object. So this writes the hash of the position of the hidden object. And then the second one is a validate object is outside box. And so essentially this ensures that the hider, right, the person that is hiding the ball, did not place it inside of a piece of furniture. And so this essentially authenticates to the other player that the player didn't cheat, right, and is playing by the rules. And also, it comes into effect when in the fully fleshed out version of Hot and Cold, because again, this is proof of concept prototype V1 of it, is that we would ensure that it is in the room, it is not in any piece of furniture, and the seeker actually doesn't know where the object is hidden until they're within a certain distance from the object. So that is very key, because otherwise the player, if they knew ahead of time, they could instantly find out the coordinates, let's say, and find the object. But with proximity, you would only have a certain idea of where it is based on the vibrations of your controller until you meet a threshold, and then it appears and then it renders. So from there, we implemented the multiplayer features via WebSockets, and we used Pusher for that. And this actually was then integrated into every part of our application, right? So this is with the front end for adding users, for inviting friends, right? So this is how people would be able to get it instantaneously, near instantaneously, I'll say. And especially then with integrating with React, Next.js, Tailwind, and Shad CN. Shout out Shad CN. Great component library. And then also, of course, implementing user account creation, login, kind of went through that already. And then we merged the multiplayer experience with WebXR. This is where a huge chunk of it took place, because anybody who's worked with WebSockets know it's not the best time in the world. And so integrating that with a WebXR experience Definitely had some unique problems to it, or maybe not problems, I'll say challenges to it. But ultimately, that was it, making sure that, well, for one, you would get in the lobby together, both players knew you were ready. Whoever was the host was the seeker, right? So it's about integrating that, and also sending over via WebSockets, client to client, your opponent's tracked information, your tracked messages and tracked planes. So they knew your room layout and knew where they could possibly hide the object. And then from there, the final feature is actually finding, well, placing and finding the hidden object, right? And so that's kind of in the last step as well. Well, that is part of the last step as well, but very key to the game, of course, because both clients need to know where the object is. Otherwise, how would you ever find it? Kind of self-explanatory. And yeah, so I guess I'll add the flashlight feature. As you'll see, it's pretty cool, to be honest. We simulate a flashlight, so it's not like it's just kind of you're in your room, but your room's dark and you can only clearly see where your controller's pointing, as you'll see in the demo coming up. And so now we're going to lead into like the general architecture of it, including just the game itself and with Mina. So step one, room scanning. I'll go through this pretty fast because I was going through it during the milestones. So player one hides it, right? Player two is the seeker. So the hider scans their room, it detects all the planes and messages, and same with the seeker. And then we have nicely laid out the virtual representation of both rooms, right? Including the boxes of mesh, which think of it as your furniture that you make during the space setup in the quest. And then the walls are essentially all the planes and the ceiling and the floor as well. And then step two, object hiding, right? And I'll just mention, of course, during that period, you have to send it to each other. You have to send each other's room layout. So if you don't want somebody knowing what your room layout's like, I suggest not playing with them. But nonetheless, yeah, so now we have to hide the object. And so you can see we have the red ball hidden somewhere in the room. And ideally, and I say ideally because there were problems compiling the contract with 3GS, it seemed, specifically compiling the smart contract locally. And may have had, I believe it had to do with headers. It also had to do with 3GS itself because we use that in part of the utils to essentially run the method, right? Because we use their properties like vector3, matrix4 to ensure everything was in place. But ideally, that compiles, and then right when the hider places the object and confirms they want it there, that's when it commits the hash of the object's position to the Mina blockchain. And then from there, once it's committed, the position of the hidden object is validated against all the planes and boxes that make up the seeker's room. And then this allows the seeker to have that certainty that the object is not inside a piece of furniture or outside the room without the hider having to disclose the actual position of the object. And that goes back into the proximity mode I was talking about before. So only when you're within a certain range does the other client finally know the exact position of the object. So yeah, final step, object seeking. Seeker tries to find the hidden object in the room. And again, if the seeker manages to find a hidden object, its position is compared against the previously committed position to verify that it's the correct one. And yeah, so that's it for the slideshow presentation portion of the video. So now let's hop over to the actual application flow. All right, great. So now we are going to demonstrate the actual application. And all of this was recorded on Raphael's and my Quest. So forgive the quality. It seems to have gotten compressed along the way. But nonetheless, here it is. So I'm going to start the video. From here, this is just a very simple landing page, and I'm going to sign in through GitHub. And once I sign in, we land on the dashboard. And from here, you have essentially your account. And so right here. Nothing else is really laid out. The only thing we fully built out on the UI side in the dashboard was the friends list. And now Raphael is going to sign in as well. And as you can see, we have the authorized Clerk because we're doing this through Clerk. So shout out to them. And now he signed in. Beautiful. Nice voice crack. All right. So from here, I'm going to type in Raphael's username because that's how users find each other in our application. And so add friend, bam, he shows up. And so now I'm just going to add him and he gets the friend request immediately. Thanks to WebSockets, specifically Pusher. And so now he's going to accept it and then it loads up. Nice. And it reflects on my end as well. All right. And before we go into the actual game, just going to demo the sandbox mode. It's nothing too crazy. It's just actually a really simple layout. It's just really two balls laid out in a box. Don't mind the box. But there, your room has physics to it. So it is attached to the digital world. And that is thanks to the WebXR standard, Meta for sending over all the space setup information. All right, so now what's going to happen is I'm launching into the create match. And from here, what we're going to do is I'm just going to invite Raphael. So once I invite him, he's going to get alerted instantly on it as long as he's in the dashboard. Well, anywhere in the application, frankly. And from here, bam, pops up and he joins. So this is the actual hide and seek part of it. This is how Cold and work. So here we're in the lobby. So when he readies up, I get it. As you can see, I just readied up and he received it immediately. And so here's where we would toggle Mina activation on. And so we have this toggle on for demo reasons. It's easier to test when you're just using 3GS, as well as there seems to be a problem with the integration part of Mina and 3GS when it comes to compiling the contract, as we explained earlier. So yeah, all we're going to do is launch a game once both players are ready. Bam. So now Raphael's in my room. So you could realize that that's my bed. The desk to the left, that orange part, that's my other desk, and there's a desk behind me. What he's going to do is just place this object somewhere in my room, right there, and then when he clicks X and Y on his left controller, now boom. So right when he places it, my controller starts vibrating, and now I'm looking around my room trying to find the ball. And with some cool shaders, we're able to simulate this flashlight effect. And we also added the web frames just for safety reasons while testing. Not probably the best idea to be walking around with everything dark. And so now my goal is to try to find the ball. I have to try to find exactly where you put it. And so here's me searching. And then eventually, you can't really see it on the camera too well, but it is there. You could see actually my ray going right through it. And that's actually exactly where he put it. So we were able to sync up. He was able to get my entire room layout, place the ball where he wanted to, and then once he pressed X and Y, I was alerted and was trying to find it, and there it is. And so you'll see, bam, get it, and then it lights up. And that's the demo. Really, thanks for listening. Thanks for paying attention, especially during my bits of rambles during this presentation. But hope you enjoyed it. It's really fun making, and shout out to the team of Mina. Thanks for putting this hackathon together. Rafael and I had a lot of fun doing this. Cheers.